Hello, welcome. Today we're going to do problems using bearings, and then we're going to do some word problems using vectors. First, we're going to start off with a little bit of review. If M and N are parallel, and this angle is 40 degrees, X also has to be 40 degrees because these are called alternate interior angles. So if this is 40, Y has to be 140 because these are called a linear pair of angles, or you could say these two angles are supplementary, meaning they add up to 180 degrees. So if we know this is 40 and that's 120, let's try to find Z. 180 minus 120 would be 60. So now we have angle Z. So we're going to need these skills in order to do some of these problems. First, we need to learn about what a bearing is. A bearing is an angle measured clockwise from due north. I believe we've done this a little bit this year, but not a lot. So a 30-degree bearing, it would be 30 degrees from north. A 135-degree bearing would be down here. This is a 250-degree bearing. Now, let's do a couple drawings. So let's say that this is my y-axis and y-axis. 150 degrees would be here, a little less than 180. 225, we'd start here, and this would be 90. 180, that would be 270. So it's got to be somewhere in the middle there. So the reference angle for this vector is 65 degrees. So remember, reference angle is always the angle made when between the terminal side and the horizontal axis. So if this is 65 degrees, what is this angle in standard position? Well, standard position starts here. That would be 90, 180. 180 plus 65 would be 245. Now if I ask for the bearing is how many degrees is it from here to there? Well, if this is 65, that would mean this angle here would be 90 minus 65, which would be 25. So it would be 180 to here, and then another 25. So the bearing would be 205 degrees. Now here, we're going to do another problem. Pause the video and see if you can do this one on your own. If this angle is 20, the angle in standard position, excuse me, is 180 minus 20, which is 160 degrees. In bearings, this is 270, so 270 plus 20 is 290 degrees. Alright, now we're going to do some problems that involve vectors and bearings. Walk 38 feet at a bearing of 40 degrees, turn and then walk 24 feet at a bearing of 120 degrees. So let's start out. We're going to walk at a bearing of 40 degrees, so that's in this direction. We're going to walk 38 feet. And bearing of 40 degrees means that this angle here is 40. Now we're going to turn at this point, and we're going to go to a bearing of 120 degrees. So we have to act like we have an axis right here. 120 degrees from here, that would be 90. 120 would be about right there. And then we walk 24 feet in this direction. So this is a good diagram to represent the situation. They go up here. Oh, I should put my angle there. That's 120. So how far are we from where we started? Well, we started here, and if I draw that vector in there, finding that vector would help us out. So we know that if this is 40 degrees, this angle in here has to be 40. Now if this is 120 degrees, this angle in here has to be 60 degrees. Now there's a triangle in here, but it's kind of confusing, so there's so much in here. So I'm going to move this off to the right. And now we know 40 and 60 would make up 100. And this side is 38, this side is 24. And now we just need to find this side. Now we have side angle sides, so we're going to use law of cosine. So c squared is equal to 38 squared plus 24 squared minus 2 times 38 times 24 times the cosine of 100. Now if I type that into my calculator, 38 squared plus 24 squared minus 2 times 38 times 24 times the cosine of 100, that's going to be 2,336.7, and I'd have to square root that. So c squared is 2,336.7, so square root that, so c is 48.3 feet is this distance. That's how far they are from where they started. Alright, so what bearing could have you taken to walk to that point directly? So if I just wanted to just take that path, well, this is 40 degrees plus whatever this angle is here. So now we need to find that angle. There's a couple different ways. We could use the law of cosines using the three sides, but I think it's a little easier to use the law of sines and just find that angle because we have a 100. So I'd say the sine of 100 over its opposite side, which is 48.3, is equal to the sine of theta over its opposite side, which is 24. So 24 is sine of 100. Divide that by 48.3, and sine of theta is going to equal 0.4893. So if I take the inverse sine of that, my angle will be 29.3 degrees. So that's going to be that angle there. So if I want to find the bearing, I take 40 plus 29.3, or 69.3 degrees is the bearing they could have taken in order to walk to that point directly. It's kind of a tricky problem. Oh, I forgot I went through this slower. Alright, now you guys try this. A ship sails 35 kilometers per hour at a bearing of 110 degrees. The current flows at 5 kilometers per hour at a bearing of 205 degrees. Try to represent this situation. So pause the video and see if you can get through all of these questions. That was the worst line ever drawn, I believe. I think I have a line feature. Lines. Okay. Here I can draw my lines a little bit nicer if I do this. So at a bearing of 110 degrees, so this is 90, 135, so 110 would be somewhere right in there. It's going to be 35 miles an hour, so that's a pretty big vector. And then there's a current that flows at 5 kilometers per hour at a bearing of 205. So if you want to see where that ship is actually moving, you want to add these two vectors together. So that means I put the second vector at the end of the first one. So out here, I put a vector at 205 degrees. This is 180. 205 would be out here. And it's just a 5 kilometer per hour. So it's a very small vector. So now if I want to find out what speed the ship is actually moving, I'll go to my line, or it's going to go right there. So we know this whole thing is 110 degrees. So that means this angle here is going to be 20 degrees. And if that's 20, that one there has to be 20. Alright, on this other side, we know that this is 205 degrees. So there's a 90-degree angle here where it's kind of tough to see. But this goes past 180 by 25 degrees. So 90 minus 25 is going to be what's left on this side. So that's going to be 65 degrees is here. So we need to add up those two angles to get the entire angle of 85 degrees. Now I know this length is 35, this length down here is 5, and we can use those to use the law of cosines to find this side. So c squared is equal to 35 squared plus 5 squared minus 2 times 35 times 5 times the cosine of 85. 35 squared plus 5 squared minus 2 times 35 times 5 times the cosine of 85. Now I get c squared is equal to 1,219.5. Now I square root that to get c is equal to 34.9. Now so this distance here, this is a much better drawing than what I had, but this distance here is 34.9. So with that being said, what bearing is that actually moving in? So we're looking for that angle there. We found out this angle was 85. The side was, what was that, 34.9. So we could say the sine of 85 over its opposite side of 34.9 is going to be equal to the sine of theta over its opposite side of 5. So cross multiply and divide, and the sine of theta is going to be 5 times the sine of 85 divided by 34.9. So the sine of theta is 0.1427. And now I take the inverse sine, because we know that's not over 180 degrees. So, or over 90 degrees, I should say. That's 8.2. So if that's 8.2, this is 110. We are 118.2 degrees for bearing that the ship is actually moving. Alright, hopefully that helps you out with your homework. Good luck.